100,000 tons of sunflower. Sorry. Okay. More than 100,000 tons of sunflower oil was found containing more than 2,000 ppm mineral oil. It's very serious. So this incident greatly pushed the research of mineral oil. And in 2012, EFSA published the first official report in the world. It's named the Scientific Opinion on Mineral Oil Hydrocarbon in Food, and it confirms the health risk of more. From that time, the development of analysis technology was greatly accelerated. In 2015, ISO published its first standard method, although it can only determine MOSH above 50 ppm. Later to 2017, European Union finally launched the standard 16995 2017. By this method, both MOSH and more can be determined as the LQ low to 10 ppm. And this method becomes a major solution in worldwide. China also gave a new method for qualification in 2019. The LQ is 0.3%. In 2020, Germany DGF developed the EU 1695 and pushed the LOQ to 1 ppm to satisfy the requirement of EU regulations. And nowadays, ISO is discussing a new method, 20122. It's a deeply optimized method of DGF. Next page. By reviewing this history, we clearly notice that there are two challenges in technology. First, the separation and the purification. Actually, edible oil is a kind of very complex matrix. It includes TAGs and natural paraffins, natural olefins. This may dramatically interfere the determination. And second, the quantification. The content of more is usually very low and the composition is very complex. So how to find out them and separately integrated MOSH and more is also very important. Next page. Thank you. So to solve these problems, people have developed a different method, offline method and online method. TLC and GC-FID is the offline method, and LC-GC FID and GC-GC TOF is online method. Next, I will introduce this method in detail. Okay, next page. The most representative qualitative offline method is China official recommended method 37416 2019. By TL, the principle of this method is that the polarity of edible oil and mineral oil is different. By TLC, they can be separated and colorated. Therefore, you can know if the sample contains mineral oil or not. But the biggest problem is the sensitivity of this method is not good enough. LQD is 0.3%. So to the most of the sample, you cannot use this method. Okay, next page. The current ISO 17780 is a typical offline GCFID. The rule of manually packed silver modified silica gel more and olefins was kept on the column, and more can be flowed out. You can see the right side, the chromogram of sunflower contained with lubricating oil. The hump, please notice that I use hump, not peak, to introduce mosh, because this hump contains a lot of compounds and their peak. So in the determination of mineral oil, we usually calculate the real content by the hump. The one, the weakness of this method is it cannot qualify the more. So, unfortunately. Next. Even regardless, the method only can detect mosh. There are still some weaknesses cannot be ignored. The weakness for one is low sensitivity. Although large volume emitter (LVI) are used in this method and can provide a maximum injection volume up to 50 microliter. Considering the hump wise is usually more than 10 minutes, so the height of the hump is very low. So the LQ have to be set above 50 ppm. The sensitivity is not good enough. Okay, next. Weakness two is the hump is unnoticeable to the low content sample because the hump is unapparent and baseline interferent significantly. Okay, next. Weakness three is the possible contaminant. Although the silica gel and all glasswares are pre-treated well and carefully, but usually there outcomes some undeserved peak of alkanes. You can see the needle peak on the hump. It's the undelivered contaminant from the outside. Okay, next. And weakness four is the interference. We cannot usually, although the column of silica gel can remove most of interference, but to some very complex samples, sometimes it's very difficult to identify the hump. It's too much interference peak on this, and so it's also difficult to integrate the hump error and calculate the real content of mosh. Next. To overcome this problem, people developed online LC-GC FID method. This machine tandem LC and GCFID to make the whole pre-treatment and analysis process in a closed system and providing low contamination risk, low solvent consumption, and high sensitivity. The separation and clearing by HPLC column show much higher ability than manual packed column. And also the automatic operation. Okay, automatic operation provides excellent efficiency and repeatability. It's very suitable for daily quality control. Okay, next. The most improvement of the LCG online LCG CFID is that it extends the scope. Uh, Both Mosh and more could be separated and qualified in this method. You can see this scheme by a series of well-designed internal standards. The starting point of Mosh and more segment was marked. So these two segments can be respectively injected into the GC. Next page. Okay, as I have mentioned above, the LVI inlater can provide the maximum of 50 microliter injection volume, but compared to the flow rate of LC, it's still not large enough. So a well-designed interface between LC and GC uh, was designed to solve this problem. When the segment mosh or more inject into the inlater, the solvent has a low boiling point, goes faster than any other, and they go through the clearance column and reach the evaporation outlet and purged. When our target reached the end of the clearance column, the valve was closed and all of the target get into the superior column and the detector. This, I think, the most improvement in the online LCGC FID system. It's very important to know how much the recovery. Okay, later I will answer the questions. As a next page, please. Improvement three. Uh, it's also a very important improvement in this method. Two kinds of newly processed pretreatment was evolved in this method. First is a LOX. It presents aluminum oxide column. After the Morse fraction treated with a LOX, the interference of natural paraffin can be removed. And also, the AP oxidation reaction at the right side can remove the natural olefins contains the carbon-carbon double bond in this process. You can see by these two treatment, the hump of more and more become very clear. Okay, next. Nowadays, the online LCGC method has developed three generations. The precision and operability become better and better. It's now very suitable for daily quality control. Most applied the DGF method is now mostly applied, and SO 20122 is still in discussion. It will come very soon. Okay, next page. In this part, I will briefly introduce the application of a comprehensive dimension time of fly mass in analysis of mineral oil. GCGC TOF is also an online technology. It uses two columns to separate the analyzed twice. 1D based on the boiling point, and the 2D column based on the polar rate. Combined with the response of mass, the three-dimensional map can be given. Next page. Comparing the chromatogram of LC, GCFID, and GCGC TOF, we can see the hump in LCGC are furtherly separated into a lot of spots. Each spot represents a structure of more or more. We can clearly know the mass spectra and identify the interference. Unfortunately, we can just use this information to qualification, not quantification, because the response factor of different structure is quite different on mass detector. So right now, the golden standard of determination is still LC, CFID. Next page. Next page, please. Okay. Here's the example. Oh, too fast. Up page. Okay. Here's an example. By GCGC TOF spectra, the tetranoid structures can be identified from a very mass chromatogram from the senstate, which represented the senstate hydrocarbon segment in palmic oil. Okay, next page. This is a spectrum of a more complex sample in faint formula. You can see the plant sterols are identified. Also, the structure information of MOSH can be detected, and that information can help us to tracing the source of the mineral oil contaminated. Next. Here's a summary of different online and offline method. GCFID is the most economical, so you almost don't need any update of your instrument. You can do this method. Excuse me? Some noise here.
Sorry for that. Go ahead, please.
Okay, continue. You don't need any updates of your instrument. However, by this method, you can only detect MOSH, and the sensitivity and the separation factor is not good. It's not very good. GC TOF is a very powerful tool to qualification, and you can find out a lot of interference from your very complex spectrum. But this instrument is very expensive. So it's the HPLC GCFID is still the golden standard in determination of mineral oil. Yes, in most of the lab, they only use this method to detect mineral oil. Yes, next. Okay, next. In the final part, I will introduce some applications in the method in Wilma. Okay, next. In recent years, we have tested nearly 2,000 edible oil samples from more than 10 countries around the world, including crude oil, pressed refined oil, and bleached refined. All of the oil samples are directly from our factories rather than the market. The detection rate and the distribution of subfractions was shown in the table. You can see the tropical oil, palm, and coconut got the highest risk. Okay, next page. This is based on our rich experience in this area. We have invited to participate some collaboratory study of the international testing standard, such as EN revision of EN 16995, and also the discussion of ISO new method 20122. This picture is taken in French in this summer. Okay, next. Also, we have attended some official program of the new method. We have joined the collaborative study of Chinese official method for rice. You can see the lady in the middle of the picture is the project leader of Chinese government. She has visited our lab in this summer. Okay, next. Okay, that's all. Thank you for your kind attention.
Thank you, Doctor. I request for the participant to propose the questions if they have. For now, we have 2 questions over here. Dr. Yang, can you please take that?
Yes. The first question, I'd like to know how much of the recovery for online. We have did the this validation. The recovery is between 80% to 100%. To qualify the wax from rice bran, use this method. I'm not sure. The next is possible. I'm not sure. I haven't did this experiment. But this kind of this LCDC method is very useful. If you have an opportunity, you can try.
Any questions from any participant who would like to cross over here? We'll be there for another minute or 2. Dr. Zhu is there. Good afternoon, Doctor.
Oh, okay, yeah. I'm sorry, just I have a little small problem when in the beginning to access.
Yes, I read your email. Yeah.
But it's great anyway. Yeah, just I give a comments for the wax analysis. I was in the European Federation Lipids Conference. Actually, there is one report specifically for wax analysis. And what they do is that they're taking 2 steps. One step is that making the hydrolysis, so therefore to know each alcohols and fatty acids separately and then combine together. But it is a complicated analysis as well, because the isomers, the possibilities can be huge. But in that way, they can analyze details of wax. You can check the homepage of European Federation Lipids Conference, and there's a report on that.
Thank you, Dr. Zhu.
Yeah.
I think there are no more any questions. I would like to thank you, Dr. Wang Yang, for his excellent presentation of analysis of mineral oil, hydrocarbon, and edible oil. I would like to thank as well Prakash Datta, President of IRBO, Mr. Ajay Jhunjhunwala, President of SCA and a board member of IRBO. I would like to also announce the 4th lecture in this series would be announced very soon, and the topic would be standards and regulation on contaminant in fats and oils. The circular regarding this will be circulated very soon to all the participants so that you can join the lecture. Thank you, Dr. Zhu, for joining us, and come to Dr. Yang for your wonderful presentation again. Thank you for all the participants for participating. Thank you all. Thank you very much.
Thank you. Thank you very much.
Thank you.
Goodbye.
Goodbye, sir. Goodbye. Thank you.